Hey guys, this is one of my helpers. This is Samantha. This is my Sam, and she's been keeping me company while I'm making all these videos. All right, let's get back to work. So we left off talking about acids and acid mine drainage. And this is typical in older mining locations where they extracted sulfide minerals. But I did want to add that it can occur naturally because nature can expose sulfide minerals at the surface. And then the same thing is going to happen. Those minerals will start creating natural acidic waters. But anyway, let's take a look at some more contaminants that can affect our water systems. There's carbon-containing compounds, and one of the most famous of these is DDT, which is dichlorodiphenyl trichloroethane. You can say that like 9 times really, really fast. And this was an insecticide that was very, very effective. But it also had an impact on birds, because when birds would get this in their system, their eggs would end up, the eggshells would be very thin and very brittle, and so birds were not able to properly incubate their young. And this is why when I was a kid, the bald eagle was a endangered species, because DDT had really decimated its numbers all over. And fortunately, this is no longer used in the US, and bald eagle populations have rebounded. So that's one example of a carbon-containing compound. Other carbon-containing compounds that can be bad for the environment are hydrocarbons. And hydrocarbons are basically crude oil and a natural gas. Hydrocarbons, that refers to the fact that these are chains of carbon molecules with hydrogens bonded to them. And these hydrocarbons, basically think of as like oil spills and things that would enter the environment. And this is one of the kind of weirder pollution types that you probably don't even really think of, and this is thermal pollution. Well, anytime we see that thermal word, we should be thinking of heat, right? And that's exactly what this is. This is elevated water temperature. And this is mostly the result of generating electricity, or also industries that use water for cooling processes can create thermal pollution, because they'll end up discharging this water that's hotter than what would normally be found in the environment. And this can actually disrupt biological communities because, for example, certain fish are like cold water fish, and if your water is too warm, well, they can't live there. And that's what I mean by it can disrupt these biological communities. Now, the good news about this is it's usually localized. This isn't going to be one of those things that's all over the place. It's going to be right where that hot water is discharged. Agriculture, farming, causes pollution as well. And this is because they use a lot of chemicals to help make the crops grow. For example, fertilizers, right? So we have nitrates, phosphates, and potash. Potash is potassium salts, and those are our typical fertilizers. And as I said earlier, that causes this eutrophication, those elevated nutrient levels in water. And this is just looking at nitrogen. We could make similar maps showing the other fertilizer compounds. But in these darker colors, that's high concentrations of this particular nutrient. And as you can see, where we have a whole lot of farming, we also have a whole lot of that type of pollution. Now, herbicides and pesticides are also used quite a bit in farming. Herbicides kill weeds, pesticides kill insects that would be detrimental to the crops. And if too much of this is used, some of it can wash into our water systems, right? They can go into our rivers and lakes. And these things are designed to kill. They can start killing organisms in the water. Can kill some of the algae or some of the other little organisms that live in there. And this is something we went over when we went over soils. We talked about sediment pollution, right? Where we get this soil erosion washes this sediment into the rivers and lakes. And this results in a few things. This is going to reduce the photic zone. The photic zone is the depth that light can penetrate water. And if we have a whole lot of like silt and clay and mud going into a body of water, that body of water is going to get murky and light will not be able to penetrate as far. And this could be very detrimental to photosynthetic organisms because they're not going to get that light that they need to live. This can also kill organisms that need clean water. Again, certain fish species and things need clean water. You end up getting this murky water, that's going to kill them. And it's also going to make flooding worse because this sediment is going to fill up the channel where the water used to flow. So we are, just by getting this extra sediment in there, we're kind of raising the level of the water in that stream, so then when a flood does come, it's going to be worse. So what do we do to try to clean up surface water? Well, one thing that's done in certain circumstances is dredging. See, some pollutants will stick to small sediment particles like clays. And so removing the minerals that these pollutants have stuck themselves to then removes the pollution. And the only problem with dredging, which is removing that sediment, is it increases the turbidity. So while you're digging this stuff up to remove it, you're also kind of churning it up and making the water muddier. This can remobilize some of the pollutants, get them moving around in the water system again. And then we're also left with okay, now we've got this pile of contaminated sediment. How do we dispose of that? What can we do about that? And so it can be effective, but it's not going to be appropriate for all circumstances. We also have sediment isolation, and this is where, again, since many of these contaminants might stick to those little sediment particles, what we can do is place this impermeable barrier between the water and the sediment. So now we've kind of isolated the contamination from the water. Now, this can be okay, but it's of course not going to be practical for large bodies of water. This isn't something you're going to try to do for the Great Lakes. It's just the size is not appropriate. And in addition to that, those contaminants are not removed. They're still down there. It's just they've been isolated from one particular body of water. Now, we can also use something called chemical treatment. And chemical treatment is where we add chemicals to the contaminated water, and that makes whatever the contaminant is insoluble. So basically we add something that's going to bond to the contaminant, and when it bonds to the contaminant, that contaminant becomes insoluble, so it drops out of the water. And this, again, can be effective, but we have to also add how are these chemicals we're adding going to affect the ecosystem? Are they toxic to things that are living there? That might be something we have to consider. So in all of these surface water cleanup techniques, one thing we're seeing is there are advantages and disadvantages to using them. Now, another surface water technique is decontamination. And this is filtering the contaminants out of the water. So basically, we pump water out of our stream or our pond, run it through a filtration system, and then put it back in. So we're basically filtering out those contaminants. effective, but not practical, again, for really large bodies of water. And then we also have something called bioremediation. Well, there we see this term bio. That means we're involving life. And in bioremediation, we're going to add microorganisms to the water, little bacteria or so, that metabolize the contaminant. Basically, they eat the contaminant. That's their food source. And so the idea is we add these things to that contaminated water. They eat up all of the contamination. Once they've done that, there's no more food for them, so they starve and they die, and our water is clean. But again, we're introducing some new organism to this environment. How is that going to affect the ecosystem? So these are some surface water cleanup techniques that are used. And one thing I didn't say, but you should remember, is an important part of cleaning up contamination is simply also stopping the pollutant from entering the system, right? If we have a leak from some chemical plant or a pipeline or something like that, fix the leak, right? Stop the contamination from entering the system. That's kind of problem number one to solve, and then you can try to clean up whatever surface water is contaminated. Now, as far as eutrophication, where we have those algal blooms that then use up all the oxygen in a body of water, the way we can treat that is a method called aeration. And aeration is adding oxygen to the water. You'll actually see this being done all over here. You know, lots of the subdivisions in this part of the world have these like lakes and ponds, and they usually have a fountain in them. And part of what that fountain does, other than like looking pretty, the water comes up and then it kind of churns up when that water lands. It churns up that surface water. That's helping add oxygen to that little pond or lake that you might see. And so this aeration, adding this oxygen to the water, prevents the going to anoxic conditions, right? It prevents us from having no oxygen in that surface water. All right, in addition to surface water being contaminated, our groundwater can also be contaminated. And in this case, we have a few terms that you have to remember. The contaminant plume is going to be this area of contamination in the groundwater. And when we describe contaminants, we can describe them as miscible or immiscible. Miscible contaminants mix with water. Immiscible contaminants do not mix with water. So something that's immiscible, if you ever have oil and vinegar salad dressing, you know how the oil and vinegar really don't like mixing? That's immiscible. All right, so some of these things that we might have. Okay, let's take a look at my little diagram right here. And so we have a point source. I don't know what point source this is, but it's some sort of source of contamination. And we're looking at three possible contaminant plumes that we might have. We might have something that's immiscible, and that's sitting on top of the water table, right? It doesn't mix with the water. Here, these are two possible things that can happen to a miscible contaminant. If that miscible contaminant is light, it will tend to stay near the top of the water table. If that miscible contaminant is heavy, it's going to tend to sink downwards towards the bottom of that particular aquifer. So when we're trying to treat groundwater, we really need to know what is our contaminant and how is it going to behave in the subsurface. And so we have a few things that we might use when treating this groundwater contamination. You might use something called pump and treat. And pump and treat is where we remove the contaminated water, run it through a filter system, and then re-inject it back into the aquifer. So we're filtering out whatever contamination that is. You might also have selective removal. If you have something that's immiscible and it's kind of stuck on, floating on top of the water table, you might just drill underground and selectively take out that contaminant and just leave the water underground because it hasn't mixed with that water. You might also use what's known as in situ decontamination. This word in situ means in place. So that means we're not removing any water. We're dealing with the contamination while leaving the water underground. And what you might do is immobilization. And this is where you'll inject chemicals that cause the pollutant to become insoluble. So it bonds with the contamination, precipitates out of the water, and now it's no longer in the water system. And this is the part where I'd normally be asking you guys, so what might some problems with this be? And I obviously can't hear you guys answering me, but I'm going to assume that you're sitting there behind your computers and saying, oh, well, the contaminant, that when it precipitates, it's then going to precipitate out, filling up the porosity, right? It's going to fill up the open space in the aquifer. So that's going to mean our aquifer has lower porosity and permeability, which means it is now not as good of an aquifer as it once was, because it is not going to be able to hold as much water. Now, another type of in situ decontamination is bioremediation. And this is, again, injecting these little specially designed microorganisms into the contaminated water. They're going to metabolize, they're going to eat up that contamination until it's all gone. Then they're going to starve and die out. And our contaminant is going to be gone. Now, of course, groundwater cleanup is going to be just like surface water cleanup. The number one thing that you need to do is stop the contamination from entering the system, right? And then worry about cleaning up that groundwater. So we live near Galveston, and I hope all of you guys have been to Galveston. But I've been there a couple of times, and I don't like to go there, mainly because I think water should look like this. It should look blue. And look at that beautiful beach. And this is up by Sangabeg in northern Scotland. This is actually on the north coast of Scotland. We've got this beautiful blue water and that nice beach, and that water is nice and crisp. It doesn't feel like you're sitting in a nasty, raunchy jacuzzi. And that's one of my favorite places to go. So anyway, that's it for water quality. I'll see you next time.